Hi, my name is Hannah Bangan. I got assigned problem number 4, which is section 3.3, number 19, on page 231. So the equation for number 19 is 2xy double prime minus y prime minus y equals 0. So the instructions for 19 are find two linearly independent Frobenius series solutions for x greater than 0 of each of the differential equations. So to start with, I'm going to divide the whole thing by 2x. So then that you're left with y double prime minus 1 over 2x y prime minus 1 over 2x equals 0. So next I'm going to take the limit of each, and so this is your p of x, and this is, oh, I forgot the y here, and this is your q of x. So I'm going to find p naught, which is equal to the limit as x goes to 0 of x times p of x, which is just this right here. So that's times 1 over 2x, and it's negative, which is then equal to, so then these x's cancel out, which is then you're left with negative 1/2. And then for q naught, you get the limit as x goes to 0, x squared times q, which is this value right here, so times negative 1 over 2x. So the square cancels out with this x. So then you're left with the limit as x goes to 0 of negative x over 2, which is just 0. So because both of these have a finite answer, x equals 0 is a regular, singular point. So now we can find the two roots. So we do r times r minus 1, and then you have to subtract because the root here is negative 1/2, so minus 1/2 r plus our q naught, which is just 0. So plus 0 equals 0. So if we factor this out, we get r squared minus 1.5 r equals 0. And I'll just, this is just 3/2. So 3/2 r. So then if we factor out an r, we get r times r minus 3/2 equals 0. So then we get r1 is equal to 3/2 and r2 is equal to 0. So now that we have those values, we'll come back to them. But first, we are going to use the series. So we have the y equals e to the n equals 0 infinity times c sub n x to the n plus r. So then we're going to find the derivatives of the derivative of this, which is y prime equals e sub n equals 0 to infinity of n plus r times c sub n x to the n plus r minus 1. And then we have to find the second derivative so that we can plug it back into our original equation. So we get e to the n equals 0 infinity times n plus r times n plus r minus 1 c to the n x to the n plus r minus 2. So now we are going to take these three values and plug it back into our original equation, this one right here, not the one after we divided by 2x, the one before. So if we do that, we will have 2x times e to the n equals 0 to infinity times n plus r times n plus r minus 1 times c to the n x to the n plus r minus 2. And then we're going to subtract y prime, so minus e sub n equals 0 to infinity of n plus r c sub n x to the n plus r minus 1 minus y, and I'm going to have to write it down a line because it doesn't fit. So minus e sub n equals 0 to infinity of c sub n x to the n plus r equals 0. So then if we go ahead and factor the 2x in, and if we re-index the y to have it be n plus r minus 1, this is what that line looks like. So after we substitute in the 2x, we will get e to the n equals 0 to infinity of 2 times n plus, 2 times n plus r to the n plus r minus 1 c sub n x to the n plus r minus 1 minus, then we have this value right here, and that's just the same because it's already all factored and it already has n plus r minus 1 as x to the n plus r minus 1. So we just rewrite that, n plus r c sub n x to the n plus r minus 1. And then we subtract our other value. And so for this value, we want this right here to become n plus r minus 1. So in order to do that, we have to subtract 1. So when we get that, we get e to the n equals 1. And I'll show you in a second after I write this out why that has to be like that. It has to be to n equals 1 because if we plug that in here to 1, it would, in right here, it would be, if it was still 0, it would be c to the negative 1, which we can't have, so we have to have it start at 1, so 1 minus 1 is 0, so then we get c naught. And this whole thing equals 0. So, I'm going to check the time real quick to make sure. So I'm at 9 minutes, so I'm gonna just simplify this equation right here, and then I'm probably gonna start a new video. So, in order to get it so we can actually combine each of these three values, we have to get this guy right here to be n equals 1 and this guy right here. So in order to do that, we actually have to plug in n equals 0 to those two equations, and then we can start at n equals 1. So when we plug in 0 into this equation right here, we get 2r times r minus 1 c naught x to the r minus 1 minus, and then when we plug in n equals 0 here, we get minus r c naught x to the r minus 1. And now we can go ahead and add on our we can go ahead and add on our sequence for when it starts at n equals 1. So I'm going to write it down here to make sure it all fits. So we get e to the starts at n equals 1 to infinity. So we do 2 times n plus r times n plus r minus 1 c sub n. And then we subtract that from the next sum, which is n plus r times c sub n minus the n minus 1. And that's all times x to the n plus r minus 1 equals 0. So this right here goes with this. And it also goes with this. That's just at n equals 0. And then this goes with this. And this is n equals 0. And this goes with this. And that just stays the same. Okay, so I'm going to stop here. I'm going to start a new video, and I'm actually going to go ahead and do each of the 2 cases.